Implicit differentiation is used when you cannot isolate the y value, so the function that you're solving for. You have a variable and you cannot isolate to get just y equals. So for example, in number 1 here, we can't solve this for y. We have y right here, we have y right here. We can't solve this to make it say y equals so that we could just use some of our regular derivative rules and tricks to be able to solve the derivative. So because we can't isolate our variable, we can't make this just say y equals. We have to use what's called implicit differentiation. And that means that we differentiate both sides of an equation with respect to x, and then we solve for dy dx. So implicit differentiation means we differentiate both sides of an equation with respect to whatever your variable is. Which in many cases is x. And then solve for dy dx. And remember, another way of writing dy dx is y prime. So if we are using implicit differentiation, we have to take the derivative with respect to the variable, and then we have to solve for dy dx, which is also y prime. So let me show you what this looks like. In number 1, we can't isolate our variable. If we could solve it for y equals, we could solve down and we could do our derivative normally. We can't. So there's a few things that we need to recognize. Right here, we have a little mini product rule. X squared is the first term, y is the second term. So we need to take the derivative of every single thing as we go the whole way across. So the derivative of x to the third, that's not so bad. We can bring down our power and we can subtract 1. So that will look like 3x squared. Then for the next part, we have x squared y. This is a little bit harder because it's a product rule. So we need the first, which is x squared, times the derivative of the second. Well, I don't know what y is. I don't know what the y equals function would look like. So I have to remember that I need to take the derivative of y. I don't know what the function is to take that derivative, so we just put y prime in its place. So we have first times the derivative of the second, plus the second is y, times the derivative of the first, which in this case is 2x. Then we do it again, plus. We have 4y to the second. Well, normally we would just bring down our power and subtract 1, and that would give us 8y. But I don't know what y is. So that means I have to remember I'm taking the derivative with respect to x. So I have to consider y's derivative would be whatever y prime is. And then we need the derivative of 6. The derivative of 6 is 0. Now we have a y prime right here, and we have a y prime right here. So we're going to group those two terms together. So we have x squared, y prime, and then we have plus 8y, y prime. And let's move everything else to the other side of the equal sign. So if I move everything else over, that's going to be minus our 3x squared. From right here, we're going to subtract our 3x squared from both sides. And then we have plus y times 2x, so we need to move that to the other side. So minus, I'm going to rearrange the order. I'm going to make it 2xy. Now we still need to solve for y prime. So what we need to do is pull out a y prime. And if we factor a y prime out of both of these terms, we'll be left with x squared plus 8y. Remember, when you factor it out, you have to always be able to distribute and get back to what you had. And then on the right, we still have 3x squared minus 2xy. Now we still want y prime by itself. So to get y prime by itself now, we need to divide both sides by this extra term that we have here, this x squared plus 8y. So we need to divide both sides. So that is going to look like our y prime is all by itself now on the left. And then on the right, we have our negative 3x squared minus 2xy in the numerator. That's what was there from before. And then we've divided it by our x squared plus 8y. So if we were to get values for x and y, we could substitute them in and then we could find the exact value of the derivative. But now we found the derivative with respect to x, solving for y prime. So this would be the result using implicit differentiation. Let's try the next one. So when we try to solve this down, take the derivative normal, but then don't forget to account for the y. So we have a product rule again right here. So the derivative of x squared, bring down your power, that becomes 2x. And then we have the product rule. We need to do the derivative of 2xy. So the first term is 2x, the second term is y. So the first 2x times the derivative of the second, which is y prime, plus the second, which is y, times the derivative of the first. The derivative of negative 2x is just negative 2. Remember, the negative right here goes with that 2x. So we have the first times the derivative of the second, plus the second times the derivative of the first, plus y to the third. Bring down your power and subtract 1. So 3y squared. And don't forget, we have to notate the derivative of y. C. Well, it's not part of the dy or the dx because it doesn't have an x, it doesn't have a y, so it's just a constant. We don't know what constant it is, but it's just a constant, so it's going to be 0. Because our variable is x and our equation name is y. So we have our y prime or our dy dx, and we have our x's listed. So same thing, anything that has a y prime with it, we're going to leave on the left because that's where everything is. And everything that does not have a y prime with it, all the terms that do not have a y prime, we're going to move. So that means this one needs to move and this one needs to move. So we have our negative 2x y prime plus 3y squared y prime. And then we have 0 over here. So let's move these over. So we need to subtract 2x from both sides. And we need to subtract, whoop, look, negative 2 right here. We need to add 2y. All right. So now we have our terms that have our y prime together on the left. And we can factor our y prime to the front. If we factor our y prime to the front, we are be left with our negative 2x plus 3y squared. And on the right, we have negative 2x plus 2y. So now we need to divide both sides so that we get y prime by itself. And we're dividing both sides by this whole term right here that is being multiplied by y prime. So we had our negative 2x plus 2y all over negative 2x plus 3y squared. We don't have any values for x or y, so this is finished. Now, a word of caution. You cannot cancel these negative 2x's right here. It is not multiplied to the front, so it's not a factor of 1 being multiplied. You cannot cancel unless it is moved to the front, so that it would be like 5 times something over 5. Then you can cancel because it's separated by multiplication. This is separated by addition right here with the plus. So you cannot cancel those negative 2x's. Just leave it be. Let's try the next one. Number 3, implicit differentiation. So if we want to take the implicit derivative here, take your derivative, bring down your power. So that's going to give us 5y to the 4th. And then consider the derivative of y, so y prime. We have another little product rule right here. Plus the first, so x squared, times the derivative of the second. Bring down the 3, keep the 2. And then don't forget with respect to y. So with respect to the variable is x. So you're taking the derivative with respect to x, and then you're having dy dx or y prime. So we're taking our derivative and we have to remember that we are with y prime. So then what do? We did the first times the derivative of the second plus the second, which is y to the 3rd, times the derivative of the first, which is 2x, equals the derivative of 1 is 0 because 1 is a constant. we have another little mini product rule right here. And within that product rule, look at it. Within that product rule, we have a chain rule. All right, we can do this. So we have our first, well, we have 0. The derivative of 1 is 0. So I'll write the 0 so we don't forget. So then we have the first times the derivative of the second. Well, the derivative of e to the x squared is e to the x squared times 2x. Remember, you have to do your chain rule on x squared. So that's our first times the derivative of the second plus the second times the derivative of the first. And there's our y prime. Now on this one, we have our y primes on both sides of the equals. There's one here, there's one here, and there's one here. So we need to group them all together. So I'm going to move this one to the other side by subtracting e to the x squared y prime from both sides. So that will leave us with 5y to the 4th y prime plus x squared times 3y squared y prime minus e to the x squared y prime equals. Now this one doesn't have a y prime, so I'm going to subtract it to the other side, 2xy cubed. And we still have this one on this right side, so plus 2xy e to the x squared. So now we can factor out our y prime. We have all the y primes on the same side of the equal sign now, so we can pull out our y prime. And that will leave us with 5y to the 4th plus, I'm going to rearrange this so that the 3 is in the front. It's a little bit easier for me to see it that way, so I like it that way better. And then we have, so 3x squared y squared minus e to the x squared equals negative 2xy to the 3rd plus 2xy e to the x squared. And we've got it moved to the front, so now we can divide by this whole huge thing right here that's being multiplied by our y prime. So divide by the whole thing. So that's going to leave us with y prime equals. In the numerator, we had our negative 2xy to the 3rd plus 2xy e to the x squared all over. And then we have our y, our 5y to the 4th plus 3x squared y squared minus e to the x squared. And this is finished. If we had values for x and y, we'd be able to substitute them in and get the actual value of the implicit derivative, but we don't have values. So we're just going to have to do the best that we can with what we have, which means that we'll just leave it here. Let's try the last one. So for the last one, I'm going to rewrite this as x plus y to the 1/2. So now when we take the derivative, we bring down the power, rewrite, subtract 1. So that becomes a negative 1/2. Now we need to consider our chain rule. So considering our chain rule, on the inside of our parenthesis, we'll have the derivative of x as 1 and the derivative of y is y prime. On the other side, the derivative of 1 is 0. And then we have a product rule again. So we have 0 plus we have the first times the derivative of the second. Well, the derivative of the second in this case is going to be the derivative of 2y. So of y squared, excuse me, the derivative of y squared. So if we take the derivative of y squared, that's going to be 2y y prime. Let me move this over a little bit so I have a little bit more space. So then we can look at the second, which is y to the second, times the derivative of the first, which will be 2x. So now we need to pull out and combine all of our y primes. So we have one right here, and we have one right here. So this is going to get a little bit messy, but that's okay. We can simplify it all down. The first thing that we're going to need to do is distribute right here. So that will look like 1/2 times x plus y to the negative 1/2 times 1, so that doesn't change, plus 1/2 times x plus y to negative 1/2 y prime equals, and then over here we have 2x squared y prime plus, and then this one we have 2xy squared. Okay, so now at least we have our y primes so that we can see them. So now we need to put them together. So the terms that have the y prime are going to go on the left, and the terms that do not have the y prime are going to go on the right. So that means that we need to subtract this one. This one stays where it is. This one we need to subtract, and this one stays where it is. So here we go. We have 1/2 x plus y to the negative 1/2 y prime minus subtracting this term to the other side, 2x squared y prime equals, I need to subtract this term to the other side, and this one can stay where it is. So 2xy squared minus 1/2 x plus y to the negative 1/2. Okay, now we have our y primes on the same side of the equal sign. So we can pull out our y prime. And that will leave us with 1/2 x plus y, the negative 1/2, minus 2x squared y, equaling all of this. So 2xy squared minus 1/2 x plus y to the negative 1/2. All right, now we can do our division. So that means y prime equals all of this. So 2xy squared minus 1/2. If you don't like it to the negative power, you can turn it into the square root in the denominator of x plus y. You can leave it as the negative 1/2 power too, if you like it that way. Either way is fine. And then we have dividing by this whole piece right here. So we'll have 1/2. Again, if you don't like the negative 1/2 power, you can switch it to the denominator and the square root. Minus 2x squared y. And this is the implicit differentiation for number 4.